Signals emerging from the transmitter before getting modulated are known as baseband signals. In practice, no baseband signal would be of any single frequency. It is spread out over a range of frequencies known as signal bandwidth. Due to this, there is always a need to modulate the signal. Suppose we need to transmit signals in the audio frequency range less than 20 kHz over long distance. Though we may expect it to be easy, provided we have appropriate medium and the receiver antennas, it is just not simple. Let us look into factors which make the transmission difficult and ways and means to overcome the difficulties. Size of the antenna or aerial. Suppose we need to transmit signals in the audio frequency range less than 20 kHz over long distance. If the wavelength of a signal is lambda, the most effective height of the transmitting antenna is approximately lambda by 4. Maximum frequency of our signal equals 20 kHz, which corresponds to a minimum wavelength equaling 15 kilometers. From the relationship C equals F lambda, where C and F are the speed of light in vacuum and F the frequency. This means that we need to have an antenna of height equaling 15 kilometers by 4, approximately 4 kilometers. Obviously, such a tall antenna is not practically easy to design and maintain. Hence, there is a necessity to reduce the wavelength or increase the frequency of the signal. Effective power radiated by an antenna. If the length of the antenna equals L, then the effective power radiated by it is directly proportional to L by lambda squared. This means that larger is the wavelength, less will be the transmitter power. We can solve this problem by reducing the wavelength, or in other words, increasing the frequency. Mixing up of signals from different transmitters. When several stations transmit baseband signals simultaneously, there are large chances of their signals getting mixed up. Just like when several people talk at the same time. This phenomenon, known as interference, is common, as you may have experienced if you listen to shortwave and medium-wave radio stations. This problem is solved by assigning a band of frequencies to each message signal and by increasing the frequency of signals. Increasing the frequency of the signal is carried out by a high-frequency wave known as carrier wave. The carrier wave can be sinusoidal or in pulses. A sinusoidal carrier wave is mathematically represented as mt equals AC sine omega ct plus phi, where C of t is the signal strength, voltage or current. AC is the amplitude, omega c is the angular frequency, and phi is the initial phase of the carrier wave. Modulation is the process in which the amplitude, frequency, or the phase of the carrier wave is controlled by the message signal. Modulation is classified into the following three types, depending upon which of the three parameters are controlled. Amplitude modulation, AM, frequency modulation, and phase modulation, PM. As pulse involves significantly distinct characteristics, pulse modulation is further classified as pulse amplitude modulation, PAM, pulse duration modulation, PDM, pulse width modulation, PWM, and pulse position modulation, PPM. The schematic diagram illustrates the different types of modulation.